Welcome to machine learning, and today we want to take you through data preparation and feature selection using the lasso technique. So for this analysis, we want to determine which factors play a role in determining the life expectancy in different countries. So we are working with life expectancy data. We are going to use the load function to load the dataset, which is called life expectancy .rda. So this dataset is also available in the description, and the next thing is to just view the dataset. And so we have a dataset in the in the life expectancy RDA file, which is called life. So that's our dataset, is called life. So this is the life dataset. You can see the first 6 rows of the dataset. You can also see the structure of the dataset. So you can see that we have 2,938 observations and 22 variables, and also you can see the names, which is the column names of the dataset. Right, so we have country, year, status, life expectancy, adult mortality, and life expectancy is our response variable, and all these are explanatory variables. So the next thing is to we want to see the number of unique rows. So for this dataset, our dataset will be each country and year combination. So let's see that number of rows and rows of unique. And our dataset is life, so we want all the rows where we only have the country column, country, and the year. Right, so we have 2,938, which is the same as the number of observations. You can see it here. Let me show you here. Run this. Right, so 2,938 observations. So that means our dataset does not have duplicates, so that one is okay. We can move forward. We can see the summary of our response variable, which is life expectancy. So we can see that it's ranging from 36 to 89, and we can see the mean and the median, they are almost in the same range. However, we see that we have NAs, it means missing values, and there are only 10 out of this large sample. So it is not wise for us to impute them, but it is better for us to remove them completely. So let's remove them. So we are going to create another new dataset, which is called life, and we are just saying in the original life dataset, let us only see where we don't have NA. So I'm saying not is NA of what? Of life, then of life expectancy. So we don't want to see NAs. Then we also take, so if anything I'm doing before the comma, I'm dealing with the rows, then anything I do after the comma are the columns. So we need all columns. If I don't do anything to the columns, that means I need all the columns, right? So we now have, if we want to check that, we can see we no longer have missing values for life expectancy. Let's just confirm. Right, you can see there are no more NAs. That's fine. So the next thing is just to see the distribution, to see if we need to transform this response variable. Remember, you will need to work with a non-skewed response variable, so we need to confirm that. So we're going to use ggplot as a function for our graphics, and the first requirement is data, which is life, and we specify our axis, which is x is equal to be the life expectancy. We want to see its distribution, so we are going to use the geom density. We want to see the density fill, I'm going to give it a blue color, and I'm going to give it a transparency of 50%, 0.5, and I'm going to deal with the theme. So my theme, I need to remove my background theme, then panel, I don't want the background, so element blank, and I also don't want the border, so panel, border, element, and I also don't want some grid lines. I just want it to be plain, element blank, and panel dot grid minor, I want it to be blank as well. Right, I can also add the labs, which is the labels. So my X labels is going to be life expectancy, right? So let's see the plot. Right, yeah, it's not perfect, but it's almost like a normal distribution. It tries to follow the pattern of a normal distribution, although we can see that we have more life expectancy around the 70s. So that's it. The next thing we are going to do is feature selection. We need to specify the features that we want to work with, so it will be wise for us to use these features. So let's select them. Let's take them from the data frame. So I'm going to say feature variables, so I'll just shorten. Then I'm going to say names of that, which is names, I mean column names, and I only need starting from 5. This is from column 5 to column 22. So those will be my feature values. So to just confirm if I have the right ones, so you can see these are the variables that I'll be working with, and also I can give a summary of them. I can see the summary of these variables. So to see that, I'm going to say life is my data set, and I put square brackets, and I said I want all the rows, but I only want these columns, which is feature fast. So what it means is that I just have listed all these columns here, but they are being represented by this vector. So let's see. Yeah, so this is the summary statistics for all the features, and you can see that we have so many NAs on different variables, NAs, and for us to make or to create machine learning models, it's wise to remove or to impute these NAs. We can't work with them as NAs, but we can also see the summary of status. We are not going to use it, but we just want to see as a factor of life. I'm saying as a factor because ordinarily it is a character. You can see here where is it, status, you can see it's a character, but if it is a character, it means they are just strings, group of strings, but we want it to show me the different categories of developing and non-developing, so I need it to have levels. That's why I'm saying factor of status. Right, so now we have these different levels. So yeah, so that's it for the first part, just exploring our data set, making our data preparation, and make our data ready for predictions and modeling. So in the next in the next video, we're going to speak about how to do missing data imputation. Thank you.